So in year 1 and year 2, the children will have a vast experience of using concrete apparatus in order to explore number patterns up to and beyond numbers to 20. They will then move on to the pictorial representation of the chips and peas. This will then lead into our abstract method, which is a mini step really towards formal addition. So they're going to draw the chips and peas to represent their calculation. So I've got a year 2 volunteer here who's going to show us how to do it. So for 23 plus 31, they're going to partition this. So they're going to draw 2 chips and 3 peas. So they're understanding the value of the places, plus 31. So they're going to know that there's 3 chips and 1 pea. What the child is then going to do is they're going to then count up, and they're going to add up how many 10s there are and how many 1s. So they've identified that there are 50, there's 5 10s, so 50 plus the 4 1s to make 54. And this can be used at any numbers up to and beyond 100. Then moving on to subtraction. From a really young age, so from reception, they will understand that subtraction, take away, means that the number is going to be getting smaller, that we are going to be putting things away. So in this case, they're only going to make the first number. So they're going to make 54 by drawing the 5 chips and the 4 peas. So really understanding the place value of this. And then what they're going to do is they're going to take away, so they're going to cross out the ones that aren't needed anymore. So the 20 and the 1. And then they can count up what they're left with. So you can see my lovely year 2 volunteer there has counted up 3 10s and 3 1s. Brilliant. This sort of method can also be used for when we need to exchange, when we haven't got enough 1s. So you can see straight away that 4 take away 8, we're not going to have enough there. So can my lovely year 2 volunteer please draw me the 34? So again, we're going to make the biggest number. So the child would then say they're going to take away 8, and they can see there, we can't take away 8 without breaking the whole. So the child is going to break the whole, and they're going to exchange the one of the 10 sticks into 10 1s, into 10 peas. Brilliant. And then now they can take away 18. And the 10. Excellent. And then they can write an equal sign, and then they can tell us what we've got left. So they can see how many chips. So this is building on from our concrete method, where they actually would have had the apparatus to handle. So they can see we've got 1 10s left and 6 1s. When learning early multiplication in years 1 and 2, the children do a lot of learning through song or through games, and they'll have a lot of hands-on approach, perhaps using manipulatives like Numicon to show repeat addition. Once they become familiar with the patterns, they would then use this to create number lines. So I've got a year 2 helper here with me, and they're going to show us how we would work out 4 times 3. So we're going to start with 0 at the start of our number line. And then this child knows through their games and through the counting in class, they know how to count in 3s. So they're going to show us how they're going to do their jumps in their 3 times table. So we've got 0, 3. So this is a blank number line method that we use. 6, 9. And as we're doing 4 lots of 3, they need to do 4 jumps. So they're going to do 1 more. And the answer is going to be at the end of their number line. So 4 times 3 equals 12. And as multiplication is commutative, they also know this is going to work the other way round. So when they're working on arrays, they would do 4 rows of 3 or 3 rows of 4. So underneath, my little year 2 helper, can you show me that 3 times 4 is the same? So this time we're going to jump up in our 4 times table. We're going to start at 0 again, and we're going to jump up in 4s. So we've got 0, 4, So we need 3 jumps because we're doing 3 lots of 4. And as you can see, we get the same answer of 12, proving that multiplication can be done in any order. But we would do this through practical number line songs, and then we would then use this to work out the inverse. So we're now going to do 12 divided by 4. So if you write 12 divided by 4 over here, 12, not 15. That's fine. 12 divided by 4. Well done. So this time we're going to start from the highest number and we're going to count backwards. So when they're doing in year 1 and 2, when we're learning the early multiplication facts, they would count up and backwards. So we're going to put 12 at the end of this number line. Give yourself a little bit of space. Well done. And we're going to count back in jumps of 4. Come this way. Well done. So we would talk about this as grouping, we talk about this as sharing. Keep going all the way to 0. Well done, so there's none left to share and there's no remainders. So then we would check this by knowing how many jumps we've done. So we've taken away 12, 8, 4, 0. And how many jumps are there? There's 3, so equals 3. 12 divided by 4 equals 3. And we all would obviously know, using the inverse, that 12 divided by 3 equals 4.